All right, so today you'll be working on your projectile motion worksheet. So I'm just going to take you through it and see what we got here. So number one is just a basic vector problem. It's getting used to vector addition, which is a little bit different than regular addition. Again, we're working with x direction motion, y direction motion. So we're going to be putting those together. This is just a basic trig problem here. So it says a boat's speed in still water is 1.85 meters per second. If the boat is to travel directly across a river whose current has a speed of 1.2 meters per second, at what upstream angle must the boat head? All right, so in other words, what that means is the boat is traveling directly across the river at the velocity of the boat, but the water is going to be pushing it down because of the current. So if we figure out the angle that it pushes it, we just know that we have to angle that far upstream so that we kind of go like this. It kind of pushes us and we end up right straight across the river. So if you look at this, the first thing you want to do is label the triangle relative to that angle. So this would be adjacent. That would be opposite. Okay, and I want to find that angle. So if I have adjacent and opposite, it should make sense that I'm going to use tan. So I'll use tangent of theta equals opposite over adjacent. I go tan theta, opposite is velocity of the water, which is 1.2. Then velocity of the boat's 1.85. Yeah, 1.85. So I go ahead and solve it. Tan theta, I do it 1.2. Divided by 1.85, and I get 0.65. To undo tangent, remember you have to take the inverse tan, so I do inverse tan on each side. So I do second tan, second answer. In my calculator, I get 32.9 degrees. So, since it would take us 32.29 degrees down the river, if I would just aim that same direction up here, that water would curve me so I come directly at the other point there. Okay, basic trig problem. All right, so let's go ahead and get started here with number 2, actual trig problems. It says, to start an avalanche on a mountain slope, an artillery shell is fired with an initial velocity of 300 meters per second at 55 degrees, about the horizontal. It explodes on the mountainside 42 seconds after firing. What are the x and y coordinates of the shell where it explodes relative to this firing point? Okay, so remember, there's two types of problems. All right, you're either going to get one that gives you initial velocity at an angle, or you're going to say it's fired out horizontally. So this one obviously gives us an initial velocity at an angle, okay? So on your equation sheet, right here, under projectile motion, tells you how to break it up. So the first thing you have to do if you're given an initial velocity at an angle is break it up into Vix and Viy, all right? So this is number 2. So the shell, let's see, let's draw some mountains here, is going to be shot and it's going to land somewhere over here, okay? So if I'm given an initial velocity, which is and an angle, which is 55 degrees, first thing I need to do is find Vix and Viy. We're going to break it up. We're going to break it up only in motion x and only motion in y, okay? You can't work in 2 dimensions at the same time. So again, I just easy plug in here. It's Vix equals Vi cosine theta. So I plug in Vix equals 300 cosine 55. All right, so I do that. 300 times cosine 55. I get 172 meters per second. Important. Got that. I do Viy. Viy is equal to Vi sine theta. Viy equals Vi is 300 sine 55. Okay? So go ahead and plug that in. I go 300 times sine 55. I get 245.7 meters per second. Once you find VIX and VIY, once you find those, you're never going to use those again. Don't use them. You're not going to use it. You can only work with variables in the X, and you can only work with variables in the Y at one time. Okay? So, in the X direction, all right, in the X direction, the only equation you have is this. Delta X equals VIXT. That's the only one you're ever going to use, because what we say is you're going to neglect air resistance, and if you neglect air resistance, nothing slows these projectiles down in the horizontal direction only. Gravity is in the Y direction, but there's nothing in the X direction. So you're only ever going to use this. If you ask for how far or a VIX, this is the equation you're going to use. All right? So, in looking at this, I know VIX, but what don't I know? I don't know time. So what I have to do is use my Y variables to solve for not only delta Y, in other words, where it's at in the Y direction, but also time, so I can solve for that. All right? Or no, it gives me time, doesn't it? Yeah, 42 seconds. I'm sorry. So it gives me time. So I know over here, let's see, VIX is equal to 172. Time is equal to 42. That's pretty simple. I can just plug in here. Delta X equals 172 times 42. All right, remember that little rant I had on other problems. I forgot we're given time here. So I do 172 times 42. I get 7,224 meters. All right, that one, X direction is always way easier. Okay, it's way easier. So now I'm going to list all my Y variables. Well, I know it starts at this, so VIY is 245.7. I know that it's in the air. Time is equal to 42 seconds. I know gravity is in the Y direction. I want to know delta Y. So once you get to this point, you use your normal kinematic equations. Okay? That's why it's very similar to one-dimensional motion. All right? Look here. I think I'm going to use this one. Delta Y is equal to VIT plus 1/2 GT squared. Delta Y is what I'm looking for. VI is 245.7. Time is 42 plus 1/2. G is negative 9.8. 42 squared. Simplify and then add. So I'll simplify first. 245.7 times 42 is a big number here. Oops. It's 10319.4 plus. I'll do this one. 42 squared times negative 9.8 times 0.5. I get negative 8643.6. All I gotta do is add now. So delta Y is equal to 1,675.8 meters. Okay, so we have the location in the X, the location in the Y of the projectile after 42 seconds. All right? Number 3 states, a child sits upright in a wagon which is moving to the right at a constant speed. The child extends her hand and throws an apple straight upwards, while the wagon continues to travel forwards at a constant speed. If air resistance is neglected, where will the apple land in Y? Well, if you neglect air resistance, all right, anything you throw up is going to come right back down as you travel, because you're going to be moving at a constant speed, right? So when you throw the marker up, it inherits the speed that you're traveling with. So if I'm traveling in the X direction at 5 meters per second, if I'm neglecting air resistance, when I throw it up, all right, to the stationary observer, it's going to actually follow a parabolic path, even though to the person in the cart, it's going to look like it's going straight up and straight down, because both of you are traveling at 5 meters per second. So the child actually catches it right back where she released it from. All right? Number 4, a tiger leaps horizontally from a 6.5 meter high rock with a speed of 3.5 meters per second. How far from the base of the rock will she land? All right? So let's draw this. We got a rock, tiger, all right, super accurately drawn tiger, no big deal. So the key to this problem, okay, like I said, there's 2 different types of problems. You saw in number 2, you were given an initial velocity at an angle. This does not give you an initial velocity at an angle. It says it jumps out horizontally. As soon as you read something is shot out horizontally or goes horizontally, you know a variable right away that you must remember, okay? VIY is 0 anytime you say horizontally, all right? So I got to write that down. VIY in the y direction, your initial velocity is 0. Okay, you have to remember that. So again, let's build this. It says the rock is 6.5 meters high, so this rock is 6.5. All right. It jumps out with a speed of 3.5 meters per second. So since it says horizontally it jumps out, we know that any velocity they give me is going to be my initial velocity in the x direction. Okay, in the x direction. So now let's kind of see. It says how far from the base. So we want to figure out this distance here. So in other words, we want to find delta x. So I'm looking for delta x. Remember, the only equation I have for the x direction is this. Delta x equals Vix t. Well, if you look, I know Vix. I need to find t before I can solve for delta x. Well, I can't solve for it in the x direction, so I must use my y variables to solve for how long the thing was in the air for, and that way I can use it and figure out how far the tiger actually jumped. So what else do I know in the y direction? Well, I know g. All right. I also know that it goes down. Again, one way has to be positive, one way is negative. One way is positive, one way is negative. So now you have to consider both directions. So up is positive, down is negative. That means it goes down 6.5. So delta y is going to be negative 6.5 meters. I want to find time. I know I'll use this one. Delta y equals VIT plus 1/2 GT squared. Again, this becomes a regular one-dimensional kinematics equation here. Vi is 0, goes away. Delta y is negative 6.5 equals 1/2 g negative 9.8 t squared. Solve for t. I get negative 6.5 equals negative 4.9 t squared. Divide by negative 4.9. I get (1.33) equals t squared, I square root. I get 1.15 seconds. So the tiger is in the air for 1.15 seconds. I can use that. T equals 1.15. I plug in. Delta x equals 3.5 times 1.15 seconds. Delta x equals 3.5 times 1.15. I get 4.02 meters. Okay? Number 4, pretty easy. Number 5 says, a football is kicked at an angle of 37 degrees with a velocity of 20 meters per second. Calculate A, the maximum height, B, the time of travel before the football hits the ground, how far away it hits the ground, the velocity vector at the maximum height, and the acceleration vector at the maximum height. All right, good. So I'm going to draw this first. Where is this? What number is this? 5? Yeah, 5. So a football is being kicked, and it's going to follow some sort of path like that. Everybody agree with that? It should make sense. I'll set up as positive, down as negative, right to be positive, left as negative. Set my frame of reference, okay? So this problem, okay, gives me a velocity and an angle. Remember, the first thing you should do is find VIX and VIY. So they give me VI, which is 37. They give me theta, which is 20 degrees. See, is that right? Yeah, 20 degrees. No, I have that backwards. 20 meters per second and 37 degrees. All right? So the first thing I want to do is, before you do anything with this problem, is you have to find VIX, all right, so I do cosine 37 times 20. I get 15.9 meters per second. I gotta find VIY. Just plug in. VIY equals VI sine theta. VIY equals 20 sine 37. VIY. So I have what? Sine 37 times 20. I get 12. All right? So, once I find VIX and VIY, I don't use VI and theta again. Do not use them. All right? You're not using it. You can only work with motion in the X, only motion in the Y. So let's see what it starts asking us here. A. So this is even before I do anything that the problem asks me to do. Calculate the maximum height. I want to know the maximum height. So in other words, I want to know delta Y. So it should be obvious that I'm going to be using Y variables if I want to use delta Y. Well, think about it. What do you know in the Y direction from here to here? Well, we know what it starts at. We just found it. VIY is 12 meters per second. So I go VIY 12 meters per second. What do we know when things get to their highest point? Well, when things reach their highest point, their velocity is 0. So my VFY, okay, gravity is always in the Y direction. I want to find delta Y. Basic kinematics equation again. All right, so I look here, I'm going to use this one. VF squared equals VI squared plus 2G delta Y. VF is 0, VI is 12 squared plus 2 times negative 9.8 times delta Y. 0 equals 144 plus negative 19.6 delta Y. All right, subtract 144. Get negative 144 equals negative 19.6 delta Y. I divide by negative 19.6. Cancels out. Delta Y equals 144 divided by 19.6. 7.35 meters is the maximum height that football reaches. Okay? We found the maximum height. B, the time of travel before it hits the ground. Okay? So what I can do here is, since it lands at the same height, right? You kick it on the ground, it lands on the ground. I can find the time it takes to get to here and then just double it, and that's my total time. Because I already have variables listed from here to here. Does that make sense? So what you want to do here is find the time it takes to go up, then double it. Okay? So since these are the variables to the highest point, I'll just find t here. I'll say, okay, now I need to find t, and that's going to be time up. All right, I can use this one. VF equals VI plus GT. VF is 0, VI is 12 plus negative 9.8 t. Subtract 12. I get negative 12 equals negative 9.8 t. Divide by negative 9.8. I get t up equals 12 divided by 9.8. 1.22. So it takes 1.22 seconds 4th to reach here. So I'll label it. So you're just piecing this together. You're building this together here. So from here to here, it's 1.22 seconds. So it means it's a 1.22 second drop down. So total time equals 1.22 seconds. I'm sorry. 2.44 seconds. All I did was add both times there. Okay? So that is B over here. C. C asks, how far away? So how far is delta x? I need to calculate delta x. Well, remember what I told you. You only have one equation. You're only going to be using this equation. Delta x equals VIXT. It's only one. I know VIX. VIX is equal to 15.9. We just found the time. For delta x, you want to use the total time because the football is traveling in the x direction the entire time it's in the air. Okay? So you want to use time is equal to 2.44. So I list delta x equals 15.9 times 2.44. Let's see, got 15.9 times 2.44. 38.8. 38.8 meters. That's how far it travels in the x direction. All right? See, D, the velocity vector at the maximum height. Okay? So in other words, all it's asking, is at this point, which way is it traveling? Well, at the highest point, is it moving up and down? No, because its velocity in the y direction is 0, so there's no upward and down motion. So the velocity vector is straight horizontal at VIX. Because at any point, if you were to go to any point here, VIX would always be the same. Always be VIX. So if at any point it asks you what is the velocity in the x direction, and you have already calculated VIX, VIX is the same at every single point. All right, VIX. This doesn't hold true for VIY. VIX. All right. Letter E, the acceleration vector at the maximum height. At the maximum height, okay, think about in the x direction. Is there acceleration? No, there is never acceleration in the x direction. What's the only acceleration that this is undergoing? Is gravity. And gravity goes straight down. So the only acceleration this has is gravity. So the acceleration vector is straight down, and it's the value of gravity. Okay? Number 6, it's supposed to say diver. A diver running 1.8 meters per second dives out horizontally from the edge of a vertical cliff and 3 seconds later reaches the water below. How high and how far from the base did the diver hit the water? Okay, so let's draw this again. This is number 6. Number 6. Diver, water. Let's see here. It gives it, so the key here is it says horizontally. Okay? So if you say horizontally, you know VIY, 0. If it gives you a velocity, which it does, it's going to be the VIX because it's going directly horizontal. Okay? It gives us the time, so I can use time in both directions. Okay? See here, is that what it does? 3 seconds? Yes, 3 seconds. So we want to know how far is delta x, and how high delta y. Positive, positive, negative, negative. So how far is really easy. We only have one equation. You're looking for delta x. The only delta x equation you have now is this. Plug in. Delta x equals VIX 1.8 times 3. You get 5.4 meters. So the diver actually goes 5.4 meters away from the cliff. Delta y is a little bit different. So I know VI is 0. I know t is 3 seconds. I also know that there's gravity. I want to find delta y. I can use this. Delta y equals VIT plus 1/2 GT squared. VI is 0, goes away. Delta y is what I'm looking for. 1/2 G, negative 9.8, T is 3 squared. Well, let me rewrite that. The 3 is squared. Delta y. See, I do 3 squared times negative 9.8 times 0.5. I get negative 44.1, negative 44.1 meters. So all that means is he travels downward 44.1 meters. All right. I know it says how high. I would accept either. If you gave me positive 44 in that case because you're describing the height, or if you give me negative 44 because that's the way he falls, that's fine. I would accept both answers there. All right. Number 7. A football is kicked at ground level with a speed of 18 meters per second at an angle of 35 degrees to the horizontal. How much later does it hit the ground? All right, so again, let's draw this picture. And again, it's really important that you draw the path that these are taking because it's going to help you build the picture. In other words, piece it together. So number 7 is just a football being kicked. So again, it takes a basic picture here. You just got to draw the path. The path is the important part. Okay? So again, this gives you a velocity at an angle. So it's 18 at 35. So VI is 18. Theta is 35. So again, angle at or velocity at an angle, first thing you want to do is VIX, VIY. VIX equals VI cosine theta. VIX equals 18 cosine 35. VIX equals 14.7. VIY equals VI sine theta. VIY equals 18 sine 35. VIY equals sine 35 times 18. 10.3. Okay? Once you find VIX and VIY, you never use this again. You never ever use it. All right? We want to know how long it's going to be in the air for. Okay? If you look at the x direction, delta x equals VIXT. The only thing I know is VIX, right? VIX is 14.7. It should be obvious that I can't use x direction. You're not going to be using x direction in this problem, so don't worry about it. Okay? So what you should do is if you're having problems figuring out if you're using x variables or y variables, is start with the x. Do you have enough information to do it? Oh, no, I don't. So I can't use x. I have to revert to y. So I'm going to put together a strategy here. I'm going to say, okay, I'll find my time to the highest point, and then I'll just double it. So find time up. This is time up. So I got to label my variables from here to here using y direction variables only. Well, I know VIY is equal to 10.3. We just found that. I know gravity is negative 9.8 meters per second squared. What else do I know? Oh, at the highest point, my velocity final on the y is 0. I want to find time. I use this. VF equals VI plus GT. VF is 0. VI is 10.3 plus negative 9.8 T. Subtract 10.3. Divide by negative 9.8. Time up equals 10.3 divided by 9.8. I get 1.05. So it takes 1.05 seconds to go from here to here, and 1.05 seconds to go from here to here. So the total time is equal to 2.1 seconds. Okay? Yep. Easy one. All right. 8. Says a ball thrown horizontally at 22 meters per second from the roof of a building lands 36 meters from the base of the building. How tall is the building? Okay, so again, the key here is it says it's thrown out horizontally. So let's go ahead and draw that. Number 8. All right, so it says, okay, we know that here it is, the ball's thrown out horizontally, and it lands, what is it, 36 meters away from the building. All right, so again, horizontally, what you know right away is VIY is 0. Got to write that down. VIY equals 0. It says it's thrown out horizontally at 22 meters per second. So horizontally, I know that's VIX, 22.2 meters per second. I know delta x, how far is 36 meters? I want to know how tall the building is. Again, positive, positive, negative, negative. I want to know how tall the building is. So how tall is in the y direction? So let's list everything we know. Well, I know VIY is 0 because it says horizontally. I know G is negative 9.8. Do I know anything else? I don't, right? So what I can do is I can find how long it was in the air for, and I can use time for this to solve for delta y. All right, because I got everything I need, I can find time here, right? Delta x equals VIXT. Delta x is 36, 22.2 t. Divide by 22.2. 36, 1.62 seconds. So I can use that in the y direction now. Time is 1.62 seconds. I'm looking for delta y. In other words, how high the building was. All right, all I have to do here is pick an equation. Delta y was VIT 1/2 GT squared. VI 0 goes away. Delta y is what I'm looking for. 1/2 G, negative 9.8. T is 1.62 squared. Just do this. All right, so I go 1.62 squared times negative 9.8 times 0.5. I get negative 12.8 meters. So the ball went down 12.8 meters, or you could say the building was 12.8 meters high. Again, I would accept either answer here. Either answer. Okay? 9. A ball is thrown horizontally from the roof of a building 9 meters tall and lands 9.5 meters from the base. What's the ball's initial speed? So let's go ahead and draw that again. Again, you're drawing this so you can see the path. All right? Number 9. Let's see here. Okay, so it's horizontal again, so let me draw the building. It is 9 meters tall. And I think it says 9.5. Yes, 9.5 meters from the base. All right? So again, the key is it says horizontally. So I know my VIY is 0 meters per second. I want to find the velocity goes off the building with. In other words, I want to find my VIX because I throw it horizontally. See, all of my initial velocity is going to be in the x direction only. So I'm looking for VIX. All right? Well, what else do I know? I know delta x is 9.5. Can I use this equation yet? No. What do I need? I need to find time before I can solve for VIX. Well, I can get time from my y direction. So let me label everything I know in the y. Well, I know gravity's in the y direction. I know that it travels delta y. The ball goes down 9 meters. And I can find time here. Using your equation sheet, pick out your equation. Kinematics, basic kinematics here. Delta y equals VIT plus 1/2 GT squared. VI 0 goes away. Delta y is negative 9 equals 1/2 negative 9.8 t squared. Negative 9 equals negative 4.9 t squared. Divide by negative 4.9. I get t squared equals, let's do the math here, 9 divided by 4.9. You get 1.83. Square root, we get time equal. Second square root, second answer, 1.35. So now I can use this over here. I know time is 1.35 seconds. So I plug in 9.5 equals VIX is what I'm looking for. 1.35 is my time. So I divide by 1.35. I get, these cancel out. I get VIX equals 9.5 divided by 1.35. 7.04 meters per second. So that ball is launched 7.04 meters per second directly horizontal, directly this way, so it goes down and travels that far in the horizontal direction. All right? 10. The pilot of an airplane traveling at 180 kilometers per hour wants to drop supplies to flood victims isolated on a patch of land 160 meters below. The supplies should be dropped how many seconds before the plane is directly overhead? Okay, so you got to visualize this one. Let's draw a picture. Number 10. So you have an airplane. And it has a package that you're going to drop. Okay? So if you wait to drop over the island, right? This is the island. If you drop it when you're straight over the island, the plane has some velocity. It has some velocity that way. All right? If you wait till you're right over it, the package is going to drop and miss. So we need to figure out what distance before. All right? So we release the package and it falls and hits the island. Okay? So let's go ahead and piece this together. The plane is flying horizontally, so I can say my VIX, because it's traveling horizontally, my VIX is, what is it, 185? 180 kilometers per hour. 180 kilometers per hour. We know the plane is flying 160 meters high. So this right here, delta, the height from here to here is 160 meters. Okay? So it's kind of pieces together. So we need to find delta x. Well, you should notice right away I need to convert this, so I'll go ahead and do that. 1 kilometer, 1,000 meters, 1 hour, 3,600 seconds. So your new VIX is 180 times 1,000 divided by 3,600. I get 50 meters per second. Okay, 50 meters per second. So I want to find delta x. I only have this equation, delta x equals VIXT. I have VIX, I don't have t. So it means I have to use y variables to figure out how long it's actually going to take the package to fall, and then I can figure out how far it's going to travel in that time. So, since it's traveling horizontally, I know VIY is 0. I know gravity, negative 9.8. We'll set this way positive, negative, negative. It is going to go down 160 meters, so delta y is negative 160 meters. Find time here. One-dimensional motion problem here. I'm going to use delta y equals VIT plus 1/2 GT squared. Delta y is negative 160. VI 0, 1/2, negative 9.8 t squared. I get negative 160 equals negative 4.9 t squared. Divide by negative 4.9. See, 160 divided by 4.9. I get 32.6. So 32.6 equals t squared, square root, and t equals. So I do second square root, second answer. I get time is equal to 5.7 meters. Oh, I'm sorry, seconds. 5.7 seconds. Okay, 5.7 seconds. I can now use this over here. T equals 5.7 seconds. So I plug in. I need to find how far in advance. So I go delta x. The plane's traveling at 50 meters per second. And it's going to take 5.7 seconds for the package to fall vertically. So we have to drop the package 50 times 5.7 gives me 285 meters. We're going to have to drop the package 285 meters in front of the island so that the package falls and hits the island. All right? Good. What are we on? Number 11? Yeah, number 11. So let's do number 11. Number 11. It says, a projectile is fired with an initial speed of 65.2 meters per second at an angle of 34.5 degrees above the horizontal on a long, flat firing range. Determine A, maximum height reached by the projectile, B, total time in the air, and the horizontal distance covered. Okay, so again, start by drawing what it looks like. The path that the object's taking. Okay, it's on a flat, long surface. So it's going to be fired, and then it's going to land and hit the same height. Up is positive, right is positive, down is negative, left is negative. All right, see what they give us. They give us a velocity initial and an angle. So I should know if I'm given a velocity initial of 65.2 and an angle of 34.5. My first step should be finding VIX and VIY. So VIX is VI cosine theta. VIX equals, VI is 65.2, cosine 34.5. So I just do that. Do cosine 34.5 times 65.2. I get 53.7. I have to find VIY. VIY equals VI sine theta. VIY equals 65.2 sine 34.5. Sine 34.5 times 65.2. 36.9. So I do 36.9 meters per second. All right, 36.9. So now, once I find VIX and VIY, I never use this again. So you're never going to use that. Cross it out. So let's look at number A, or letter A. A asked me maximum height. So I'm going to the highest point. I'm looking for delta y. Okay? So it should be obvious I'm using y variables here since I'm in the y direction. I'm going to go from here, ground level, start to highest point. Well, at the ground level in y direction, I know it's traveling at 36.9 meters per second. So VIY, 36.9. Okay? Well, at the highest point, because that's what I want to go to. I want to go to here, and that describes the highest point. VFY equals 0, because you're at the highest point. Everything stops at the highest point. I also know G is negative 9.8 meters per second squared. I want to find delta y. You look at your equation sheet. Pick an equation out here. I would use VF squared equals VI squared plus 2G delta y. VF is 0. VI 36.9 squared plus 2G negative 9.8 delta y. Alright? Solve. I'll simplify and simplify. So if 0 equals 36.9 squared gives me 1,361.61 plus negative 19.6 delta y. I subtract. Cancels out. I get negative 1361.61 plus negative 19.6 delta y. I divide by, equals. Divide by negative 19.6. Cancels out, cancels out. I get delta y equals 69.5. So that projectile reaches a height at its highest point of 69.5 meters. All right? Let's look at B. B asks you the total time in the air. Okay, I want the total time in the air. So since it lands at the same height, we can find time up and then just double it because it's the same time up as it is down. So I already have variables listed from ground to highest point. So let's just use those to find time up. So I can use VF equals VI plus GT. Actually, I'll just move that up here. So now I have B up here. VF equals VI plus GT. Velocity final at my highest point is 0. VI is 36.9 plus negative 9.8 T. Subtract 36.9. I get negative 36.9 equals negative 9.8 T. Divide by negative 9.8. T equals, that's time up, equals 36.9 divided by 9.8. And I get 3.76 seconds. So on my drawing, I piece it together. I know it's 3.76 to here. It's going to be 3.76 down. So total time is equal to 3.76 times 2 equals 7.52. All right, some total time in the air. Letter C says the total horizontal distance covered. Horizontal distance is delta x. We want to know how far that projectile is shot. Again, in x motion, this is the only equation you have. Well, now we know everything. We can plug in. Delta x, VIX from the start is 53.7. T, we want to use the total time because the projectile is in motion the entire time it's in the air. So I use the 7.52 seconds. Delta x equals 53.7 times 7.52. I do 403.8. meters. Okay, 403.8. Well, that's it for that one. Again, just stay organized, keep organized here. All right, number 12. Okay, it says, a projectile is shot from the edge of a cliff 115 meters above ground level with an initial speed of 65 meters per second at an angle of 35 degrees with the horizontal. Determine the time taken by the projectile to hit the ground level. Determine how far away from the base of the cliff the projectile strikes the ground. Find the horizontal and vertical components of its velocity, the magnitude of the velocity, and the angle made by the velocity. Find the maximum height above the cliff reached by projectile. Whole bunch there. So we're gonna piece this one together. So let's start by drawing. All right, start by drawing it here. All right, so let's see. I'm going to take this paper. All right, projectile shot from a cliff. This is number 12. Okay. Shot outward like that. Up is positive, right is positive, down negative, negative. All right. The cliff's 115 meters high. We know that, 115 meters. That's the information we're given here. It gives us VI is 65. The angle it's launched at is 35 degrees. So again, you're given an initial velocity at an angle. The first thing you have to do is find VIX, which is VI cosine theta. So I do VIX. VI is 65, cosine 35. VIX equals cosine 35 times 65. 53.2. 53.2 meters per second. Now I'm going to find VIY. VIY equals VI sine theta. VIY equals 65 times sine 35. VIY equals sine 35